All right, welcome back. Yes, we're still on polyatomic ions, and here we're going to figure out some example questions and what to do with them. So we're still looking at your polyatomic ions. You likely have this open in a tab that looks somewhat like this. Yeah, so we're going to click the example questions. That is not linked yet. This will be linked in just a second. You'll get a page that looks like this. And we'll do these 4 questions, and then I'll show you what you're going to do for practice. Off we go. So we're going to start with the formula for carbonate. Oh boy. Okay. So first things first. You're looking for the formula for carbonate. So right, and there's 4 things you're keeping track of. You're keeping track of the name is kind of the thing. So here's your circle bubble. It's got your picture inside. It's the name that's in this bubble underneath. Then your formula is below that. And your charge is up here. Okay. I should have mentioned this last time. Polyatomics rarely break apart. So they rarely break apart. They do every once in a while. You can break a polyatomic, but for the most part, they run around in this little group really well. So you can break them, but you usually will see them stick together. Even when they react, they'll often stick together in their little clump, their little polyatomic clump. All right. So your question 1 was, what was the formula of carbonate? So we are looking for a name. Carbonate is a name, and we're looking for the formula. Take your page. Carbonate's one of those polyatomics that you might see a lot. You might even have a guess of, like, you may have a beverage on your desk at this time that has carbonate in it. You might know it as another form of that word. Yeah, turns out. I'm going to let you do that in the questions. What is in your beverage that sounds like carbonate? Yeah. And you're looking for it on your page. You're looking for a name of carbonate. Your examples, I'm just going to give you some answers here. That is your carbonate. How did I know? That's the name right there. That's the carbonate. Here we're looking for the formula. So that formula is right underneath. Looking for the formula of carbonate. And we're just going to copy that down. That is CO3 with a charge of 2 negative. So that whole deal there, that whole thing is the formula of carbonate. Yeah, so that's 1 carbon atom, 3 oxygen atoms. That subscript of 3 means there's 3 oxygen atoms, and you can see them right there, 1, 2, 3. Just 1 carbon there in the middle. Carbon likes to hold hands, it goes in the middle. And its charge is -2. And that charge will go with the carbonate everywhere the carbonate goes. Which brings up some interesting questions about your beverage, potentially. We can get those too. Yeah, so that's the formula for carbonate. Let's do your next question here. Next question, what is the name of SO4 2 negative? Okay, so the name, so here you're given a formula and you're going to find the name. So we're looking for the name of SO4 2 negative. Okay. You might be starting to notice some patterns at some point. Carbonate started with carbon. This thing that starts with an S might be called something about sulfur. We are guessing there's a sulfur involved. There's all your polyatomic ions. Find the ones with the sulfurs. I'll give you some of these. These have sulfurs in them. Cool, we found the sulfurs. So far, so good. And we are looking for SO4, 2 negative. So look around. This one only has 3 oxygens. That one, though, that one has a sulfur and 4 oxygens attached. Okay, and it's 2 negative. It's got all the things it should have. It's got a sulfur. There's the sulfur, 4 oxygens, and a charge of 2 negative. All right, it's a match. Pick up its name, put its name right underneath. That is, where have you heard of that before? Is that something you eat? Where? What? The more you become accustomed to these, the more you're like, oh, these are everywhere. They're so everywhere that when I taught you ions last quarter, a whole bunch of y'all were writing this kind of stuff on your whiteboards because you were like, see, sulfate actually sounds like it should be a thing, as opposed to sulfide, right? Like a single thing, it's an "ide" at the end. But these polyatomics, all these oxygens stuck to them, that's where you come up with stuff like 8. As we go through, you're going to notice there's like a variety of things that can be on the end of a polyatomic. Yeah, but these are some really common ones: carbonate, sulfate. Let's keep ourselves rolling. Which atoms and how many of each are in PO4 3 negative? So in PO4 3 negative, you could look this up on your polyatomic ions page. I gave you this as a challenge, and now I'm giving you the answer. This is the one that we know of that has a charge of 3 negative. Okie doke. And find it on here. Find its name. You might find this on your food labels as well. But to break down which atoms and how many of each, we've got 1 phosphorus. And so there's the 1 phosphorus. That's just the question number there. 1 phosphorus. Your 4 is your subscript, so there's 4 oxygen atoms. And that 3 negative is the charge. That 3 negative has nothing to do with how many atoms are involved. That's the charge. That's how many extra electrons are stuck to it. Apparently 1 phosphorus and 4 oxygens can hold 3 extra electrons, making it an ion. And that last question is going to ask us about charge also. Oh, look at that. That last question is, what does that -3 mean? So let's do that too. Your last question there is, what does the 3 negative mean in PO4 3 negative? So we figured out it has nothing to do with how many atoms. The subscripts tell you how many. That 3 negative deal tells you the charge. So here we've got a negative charge. It has extra electrons. We've got a charge of 3. It has 3 extra electrons. Alright, that's it. And good news, that's all the things. I'm going to show you this page again. You've got the link for that. Here's your notes are right up here. And your example questions are here. Feel free to pause this, obviously, do whatever you gotta do. Yeah, I'm gonna show you how to practice with these also. What you are gonna do for practice, we just used your entire questions page, so forget that, that's done. Your practice is over here, and it's Kahoot. For your practice, click that Kahoot button and give it a shot. There's a game that I always play with these that we can't play because we're not in the same place, but here's another game. Play with a friend, that's fine also. So you click that link, you are taken here. Give yourself your correct name would be really handy. This is going to be your homework for today of figuring out kind of how to use all this polyatomic ion stuff. I think this is going to be hopefully a great method of doing it. So use some sort of name that lets me know who you are. You can do this as many times as you want. You can go through and practice. It's going to follow our table. So you have everything that you need in this link right here that we've been working with. I took the time limit off, so you don't have to worry about time at all in this practice run. Yeah, but it's going to ask you questions exactly like the questions we were just doing. And yeah, have fun. Go for it. Finish through the last question, and that's when it's going to post your score, and you actually do not need to turn anything in once you get your responses have been recorded or something like that. Once you see that on your screen, maybe screenshot it just in case, but Kahoot will also post that back to the original thing as well. So at that point you are all done. Yeah, have fun.